Hey there, I'm Brett, and today we are talking about the elimination method. Today's tutorial is part 3 in a mini-series that we are doing on solving systems of equations. Today I will be talking about the elimination method. In parts 1 and 2, I showed you how to solve systems by graphing and using the substitution method. If you haven't seen those tutorials, I recommend you do so. I'll leave links for them in the description box below. All right, let's jump into that math. When solving a system of equations using the elimination method, what you want to do is add your equations so that one of the variables drops out. Now, that means that it's really important that you have neatly written your equations so that the x's are in a column, the y's are in a column, and the constants are in a column. Next, you want to look at your equations to see if there's anything that automatically drops out when you add the two equations. Now, in this problem, it's pretty close on the two y's, but the sign is opposite. What I want is a negative 2y plus 2y. That would equal 0, and that would be really ideal here. So, since it's not already set up like that, I'm going to manipulate my equations so that they are. The easiest way to do this is to multiply one or both of your equations by a constant. In this case, I could multiply this second equation by a negative 1. And in doing so, that will make the negative 2y into a positive 2y, which when added with the negative 2y from the first equation would equal 0. Likewise, I could have also multiplied the first equation by a negative 1 so that this 2y became positive, which would add together with this negative 2y to equal 0. Really, either way is just fine. I, for some reason, like multiplying this second equation by negative 1, so that's where I'm going to start. Notice here how when I multiplied by negative 1, I made sure to multiply every single term in the equation by a negative 1 so that I would get negative x plus 2y equals negative 11. Now I'm just going to rewrite this first equation above it and add the two equations together. After adding the equations together, I got negative 7x minus x yielded negative 8x. The negative 2y and positive 2y canceled each other out, and negative 13 plus negative 11 gave me negative 24. Then I had the relationship negative 8x equals negative 24, in which I could easily solve for x, giving me x equals 3. Now, just like in our substitution method, once you find one variable, you are free to plug it back into one of the equations to find the other variable. So I'm just going to plug in x into this second equation and solve for y. So y equals negative 4, and now I have the point 3, negative 4 as my intersection point. In this second problem, once again, we're going to look at our two equations to see if anything conveniently adds away, or if we can multiply by a value in one or both of our equations to get a variable to drop out. Looking at this problem, I see that the easiest way to get a variable to drop out is here on the x's, and I could multiply this first equation by negative 6. That would give me negative 6x, and I can now add negative 6x and positive 6x to get 0. So that is how we are going to get a variable to drop out in this second equation. So after manipulating the first equation by negative 6, I get negative 6x plus 30y equals 12. Now I'm just going to transcribe the second equation below it and add them together. Alright, so for the first equation we get y equals 0, and now we can simply plug this back into one of our original equations for y and solve for x. I like this first equation, so that's where I'm going to plug it into. There we go, we found that x is negative 2. Putting these two values together, we get the coordinate point negative 2, 0. Sometimes the numbers don't work out nearly as nicely as they did in these first two problems. So in this third problem, what we have here is 4x minus 3y equals 10 and 9x plus 4y equals 1. You may notice that this time there isn't a number we could just multiply one of the equations by to get one of the variables to drop out with the other equation. And in scenarios like this, what you need to do is multiply both equations by a number so that you can make one of the variables drop out. Let me show you what that means. So here I'm going to look at the smaller numbers because I like working with smaller numbers. I have on the y, I have a negative 3y and a positive 4y. So what I could do is multiply the top equation by 4 so that I have negative 12y, and then I could multiply the bottom equation by 3 so I have a positive 12y. Then, like our other problems, the negative 12y and the positive 12y will cancel each other out, leaving me only x's. After you multiply the equations by 4 and 3, we get 16x minus 12y equals 40 and 27x plus 12y equals 3. Conveniently, the negative 12y and 12y now cancel each other out, and we can add our two equations and solve for x, which gives us x equals 1, and once again we plug this into one of the first two equations for x and solve for y. In summary, solving systems of equations using the elimination method means that you are going to combine your two equations so that one variable drops out. And if they are not already in a form where one variable drops out, you can manipulate the equations so that they are. Remember, there is nothing stopping you. You have all the capacity in the world to learn this and so much more. You may feel overwhelmed or confused at times, and that's okay. It'll pass so long as you stick with it. So please don't give up. Till next time, I'm Brett, and thank you for joining me.